So hello and welcome everyone. I hope you are doing wonderful, right? So welcome back to this another session, and today we will discuss on the topic of binomial theorem, right? Welcome back to this channel of Pradhan Academy, and let's focus. So as of the session so covered is that we have already discussed about the quadratic equations and sequential series, right? Also I took one session which is very crucial, that is we discussed about the logarithm functions, right? So in this session, we're not going to discuss about the binomial theorem part, right? And that is going to be really important and for all of you, right? So let us start the session. So I hope you have started watching the sessions from the very beginning, right? We have already covered the coordinate geometry portion, and then we started with the discussing about the algebra portion, right? So let's get started on this particular thing. So we are back on this topic of binomial theorem, right? So binomial theorem, I will tell this is very interesting chapter and an easy chapter, right? So once you have a command over the basic concepts, then you are very easy and it's the chapter is very easy, right? And once you have a good command over the basic concept, you can easily go about with the solving previous year questions. Okay. All right. Now I will give you some of the important shortcut techniques also along with the sessions. Okay. So stay tuned for the session till the end. Okay. And students who are joining for the session for the first time, I will request all of you to please hit the subscribe button and click on the bell icon, right? Because we are coming live every day where we're discussing about the important JEE Mains questions on each and every topic of maths. And this is going to be very important for your JEE Mains preparations, right? These are especially targeting those people who are basically going to give the JEE Mains second attempt. Okay, so these lectures are going to be more like revision rather than first time. Okay, so students who haven't covered the binomial theorem for the first time, I would say please try to go through the NCERT textbook. So before, as you are preparing for this the JEE Mains, your NCERT should be a must, right? So please go through the NCERT textbook of a class 11th as well as NCERT exemplar. Okay, so and practice the question from the NCERT exemplar. All right, so that is going to be really important. Okay, so please practice questions from the NCERT exemplar part, and that is going to be really important. Okay, now once you are done with this, you can you are ready to go with this particular session of discussing the previous year questions. Okay, now one more thing I would request all of you to please do is that try to make short notes. Okay, now I will tell you what is the importance of short notes is that the day you're going for the exam, you don't have the entire time to revise the entire syllabus, right? These short notes will actually help you to revise for JEE Mains. Okay, revise for JEE Mains. All right. So before you are going for your exam, you can just go through your short notes, and they will actually help you to revise the entire syllabus or entire curriculum for your JEE Mains, right? So with this particular note, I am going to discuss about the top 10 important previous year questions from the chapter of binomial theorem. So let's get started on this particular work. So our goal is basically to discuss about the concept of binomial theorem, the previous year questions, MCQ and numerical type, and also along with that, I will talk about that how questions in advance are generally asked up. Okay, and also with that, we'll try to do some paper analysis. Right now, let me tell you very precisely. I have done a little bit of analysis on the paper, and the data I have got so far is basically very interesting. Okay, so if you just look at the data, so from the previous 2024 data and 2023 and 2022. Okay, so I have done a kind of a statistical analysis of this past 24-year paper, okay, till 2021, and the result that I got is that the weightage of this particular chapter, the weightage for this particular chapter is as follows. The weightage for this particular chapter is as follows. So you can see there was a weightage of 4.5% in this 2024. There was a weightage of 6.9% in 2023. There was a weightage of 4.2% in 2022, and there was a weightage of 5% in 2021. So more or less, roughly, you can see that the average is more or less around 4.5 to 5, right? Is around 5, this kind of percentage, right? So with this, you can understand that at least what you can expect is that at least you can expect 4 to at least 3 marks, 3 questions, okay, or maybe 2 questions, okay. One question will be in the form of an MCQ, one question will be in the form of a numerical type, right? So that is really interesting to understand. And again, the chapter is very easy. So once you understand the chapter carefully, and once you start solving the problems, you will try to understand that questions are not that difficult. Once you know the concepts and how to solve those concepts and the underlying theory of the algebra behind it, you are basically ready to solve with any questions, okay. So let's start our discussion on the top important previous year questions. So here we have the first question. All right. So I would request all of you to please, if you're watching this lecture in the live, please try to solve this particular problem. All right. Please go through the problem. Try to attempt it. Okay. I will keep on telling you that what are the important ways you can solve these questions. Now, these types of questions are very, very important. Okay. Now, you must have seen these kinds of questions being repeated in a dozen of times, right? So with this, you can understand that these questions are really very important, right? So here you have a number which is given in an exponential form, and when you're dividing that particular number by a particular another number, you have to basically comment upon what is the remainder, right? And this kind of question can also be asked in the form that what is the fractional part of this particular number when you're dividing by this another number, right? So some kind of question like you might have encountered a question like you have to calculate the fractional part of some x to the power y when you divide by some number a, right? So and this curly braces denote the fractional part function. Okay, fractional part. Right. So this is what you have to discuss about, right? So I would request all of you to please try to solve this problem. At least give it a try. Okay, at least give it a try. I would be very happy if you could come up with the answer. All right. So these kinds of questions are very important. So let's see how we basically try to proceed with this problem. Okay. So we have the number that is 7 to the power 103, right? And when it is divided by and when it is so we are dividing it by divided by 23, right? So we have to basically find the remainder. We have to basically find what is the remainder we are left out when we divide this big number by a number 23 over here, right? So to find out this particular remainder, right? So how are we going to do is let us try to understand that we can use basically binomial theorem in order to find out the common factor such that that common factor get cancelled out and ultimately you're left out with one more term that will basically become the remainder term. Like my basically task is basically to try to represent this number 7 to the power 103 as some 23 times of k plus or minus some fractional part over here, right? This particular fraction f what I'm writing is must be less than, so it can be 0 and it can go up to, so it can go up to 23 22, right? So that is what I'm trying to do, right? I'm trying to represent in terms of integral part of 23 plus or minus some part which is less than 23, right? And obviously greater than equal to 0, right? So that is what my trial is to do it, right? So that's what my objective is, right? So let us see how we basically try to achieve this particular objective. Okay, so what I'm going to do it over here is that I'm simply going to play around with this number, right? So let me see that if I take 7 and multiply, I can also write the 7 to the raised to the power 103 as 7 multiplied with 7 raised to the power 202 102, right? Along with that, now what is interesting over here is that now this 102 is basically divisible by 3, right? Now why I'm doing that, you will try to understand in a minute, right? So that is what I'm doing is over here. So let us write in 7 into, now this I can always write it as, so I can always write this as 7 cube whole to the power 34, right? And also I can represent this part as 7 multiplied with, now this 7 to the power 3 or 7 cube basically becomes 343, right? Whole raised to the power 34, right? Now, now I will try to express this number that is 7 into 343 whole raised to the power 34 as, I can also write this particular number as, now I'm what is my trial is basically to write it as such that this particular inside the number that is 343, I just try to make it like some kind of number plus or minus some smaller number such that that particular number what I'm trying to write it as is divisible by 23, right? So what you see that if I take 345, it is basically divisible by 23, right? So if I'm able to take this number, if I'm able to, so I can easily make this number as, I can simply make this number as 345 minus of 2 raised to the power 34, right? And the advantage is that this particular part will be divisible by 23, right? So therefore, ultimately, what I can do, I can just simply use the binomial expansion, right? So I can just simply use the binomial expansion over here. So the binomial expansion, if I use it, it will be 7 times. That is going to be, that is going to be, so over here it's going to be 34 C0 345 raised to the power 34 minus 34 C1 345 raised to the power 33 into 2 raised to the power 1, right? And so on, so until we get the last number, and the last number is going to be plus of 34 C 34 2 raised to the power 34. That is what we have the once we do the binomial expansion of it, right? Now I can always write this part as, now since these all part wherever 345 is occurring are all integral multiples of 23, so I can easily write this part as, that is 107 to the power 103 as 23 times of some integer plus 7 times this part, right? Plus 7 into 2 to the power 34. That is what I can write as, simple, right? Now again I have to divide this particular number by 23. So this particular part is divisible by 23, but I have to find out whether this is what is the remainder I will get when I divide this 7 into 2 to the power 34 by 23, right? Now again I will try to represent this particular number as, so 7 multiplied with, now if I take 2 to the power 8, or so what I'm doing, I'm trying to take it as 2 square into 2 to the power 8, or 2 to the power 8 whole to the power 4, that is 32. So advantage is that 2 to the power 8 is 256 and 253 is basically divisible by 23, right? So therefore I can always try to write this part. So I'm just trying to figure out this the part which I'm circling out, right? So I can just try to figure this part as 7 into 4 multiplied with, now this I can write as 253 plus of 3 whole to the power 4, right? Now this part is always divisible by this 23, so ultimately you're left out with the remainder, that is 3 to the power 4, and multiply this part. So your number is going to be look like 23 some integer plus um and then this is going to 28, so it's plus some, so let us call this k dash, okay, some different integer plus this 28 multiplied with 3 to the power 4, right? That is what the integer will be looking like. So that will be basically the form, that is 28 into 81, right? 28 into 81. And if you just try to look out this particular number, that's 28 into 81, and if you try to see that how can you split this number, so I can always split this number as 23 plus 5 multiplied with 69 plus 12, right? And if you see over here, this 23 and 69 is divisible by 23. Therefore, the part you are going to left out with is that when you multiply 23 with 12 and when you multiply 5 with this 12, right? Sorry, this 5 with this 12 is going to be left out as a remainder, right? But in the all other cases, whatever you multiplied, you will obviously have that as an integral multiple of 23, right? So with this I can always write this part over here, that is 7 to the power 103 as 23 times some different multiples of 23 plus 60, right? That is what we can obviously write it up as, right? Now once we take it divided by 23, so again this particular part is going to be divided by 23, this particular part is going to be divided by it. Now 60 divided by 23 is very simple. So from this I'll see the remainder over here is going to be equal to 14, right? So 14 is our remainder. Okay, very simple, straightforward problem, right? So what I'm trying to do is basically I'm trying to represent that particular unknown number as some integral multiple of 23 plus or minus some part that is basically less than 23, right? So that will actually help you to generate the remainder, right? Now I have got it to 60, and once and the 60 is easy, right? I don't have to split it much again, so I can just try to simply take the 23 divided by 23, and I can simply take the remainder, right? So 23 2 is 46. So 60 minus 46 is going to be the remainder, that is 14, right? So with this, you will have option number C as the correct answer for this particular problem. So the remainder to this particular problem is going to be 14. I hope this is clear to all of you. Please let me know. Please let me know this is clear or not. Yes, excellent Bidhan. Excellent Bidhan. You're correct. You're correct. Your answer is 14. That's really correct. Excellent. So I hope this is clear to all of you. Maybe the way you are also solving out, it might be different, right? And like I generally pattern to use these kinds of methods when I'm basically trying to solve these questions of remainder, right? And but if you have come up with some shortcut techniques, that is totally accepted unless and until you get the correct answer, right? But I'm not teaching in shortcut for this particular part because if I go on teaching shortcuts, there will be specific cases where the shortcut will work, right? And the shortcut is not general, that it doesn't work for the general case, right? So that's why I'm not talking about the shortcut in over here in this particular session, okay? Wherever I feel that shortcut is important, I will tell you the tricks, okay? So stay tuned for that. All right. So I hope this part is clear to all of you. So let us proceed with the next problem. So next problem we have with us is again a problem where we have to basically binomially expand a particularly number over here such that the integral terms or the number of integral terms for the binomial expansion is we are having at 183, right? So very similar problem is that it's a problem where we're basically counting for the number of integral terms, right? So this is also very important and interesting as well. So this is going to be concept of general term, right? This is on the concept of general term, right? So let me tell you quickly that whenever we have binomial expansion, we have binomial expansions, for example, x plus y to the power n, then this is basically the binomial expansion formula is given as summation of r going from 0 to n, that is ncr x to the power n minus r y to the power r. That is what the formulas has to talk about, right? So here in this formula, if you look at the total number of terms, the total terms that is going to be equals to n plus 1, right? Now, if I have to talk about the general term, so general term is basically like this, right? So any general term, any tr minus 1 at term, or if I have to, so if you just look at over here, the interesting part, you'll find out that this is the r plus 1 at term. So this is nothing but the t of r plus 1 at term, okay? T of r plus 1 at term, right? Very simple. Now let us try to understand this particular problem in with respect to this context, okay? So for this binomial expansion, if I try to write the t of r plus 1 at term, so that is going to be looking like ncr 7 to the power 1 upon 3 whole to the power n minus r 11 to the power 1 upon 12 whole to the power r. That's what the general term will look like, right? Now, if I need to have integral general term, if I need to have this particular as an integral number, okay. So if I need to have an integral part, so if this part, this particular common general term should be an integer, then this particular part and the product combined product of this particular two parts should be an integer because NCR is obviously an integer. So this combined part should must become an integer, right? So let us try to understand how we are going to achieve that particular convergence. So for integer term, the r must be, so from here, if you just look over here, so for integral part, this r must be a multiple of 12, right? and and over here, so if I take up in terms, let me write it over here. That is what I'm saying is that your r is or must be integral multiple of 12, right? So therefore our r can be written as 12 times of k, where k is basically a whole number, right? So therefore for this case I will have, for this case, now since r should also be less than or equal to n, right? R should be less than or equal to n. So from this particular case, I'll see that I will have total number of r, total values of r possible, total value of r, total value of r as mentioned in the problem is 183, right? So we need to look for the integral terms. So if it is mentioned in the problem as 183, so from this we have to basically calculate the value of the unknown n, right? So what I can do over here is that at max to max, what should be the value possible for this r, right? So this r, max to maximum value of r, so maximum possible value of r is corresponding to, if I take 12 into 182, right? So if I say that r is the maximum possible value of r is 183, so if I take k is equal to 182, then the value of r I'm having it as 2184, right? 2184 is the value of r I'm having. So maximum value of r, I can just simply take it over here and put it over here, right? Because this 183 is something like, because we already know that number of terms is n plus 1, right? So similarly I'm putting it like 182 plus 1, so I'm just putting 182, right? So from this I will get maximum possible R value is like this, right? So therefore you know that maximum possible values of R must be less than the minimum value of N, right? So therefore from here I can easily comment on the minimum value of N is basically 2184. 2184 is therefore the minimum possible value of N I can have it, right? Very simple, straightforward problem, right? So from here you will have option number A as our correct answer. I hope this is clear to all of you. Please let me know if this is clear or not. Is this clear? Is this clear to all of you? This was very straightforward problem, right? So as you can see that it's just a simple problem where you have to basically find it out for the general term, right? And once you get a general term, now you must be always have a question or doubt that why are we not utilizing the fact that n minus r should also be an integral multiple of 3, right? Now I will tell you what the reason behind is that, see, if I am having this particular r as the integral multiple of 12, then n minus r, and r is basically an integral multiple of 12. So integral multiple of 12 is obviously divisible by 3, right? So what we are doing, I'm basically trying to get the largest of the 3 and 12, that is basically divisible by the both the part, right? So if I take r as an integral multiple of 12, it is obviously divisible by 3, right? But if I take it as an integral multiple of 3, then it is not divisible by 12. And that's why we basically try to choose this r that must be an integral multiple of 12. Okay, so instead of writing that r minus that particular term as an integral multiple of 3, so I'm directly putting r as an integral multiple of 12, right? So I hope this is clear to all of you, right? All right, Bidhan, I hope this is clear, right? Did you get this answer, Bidhan? All right. So if you have any questions, you can obviously put that up. Okay. And if you're watching the session after the session, live session is over, you can put that up in the comment section. Okay. I'll be very happy to answer your queries. Okay. And don't forget to join the Telegram channel from the description box. Okay. So in the description, you will find the Telegram channel link. From that, you can obviously join the channel because I'm going to share all these contents. Okay. All these particular contents in that particular session, in that particular Telegram channel as well. Okay. So I will be also posting some short notes and some questions, okay, which are very, very important for your JEE Mains preparations. So I hope that is clear to all of you. So let us proceed with the next problem. So next problem is again an interesting problem, and it is talking about, now this kind of problem has been already been asked in our, if you look at your JEE Advanced problems, you will see that this kind of problem has always been asked in JEE Advanced as well. Okay, so if you just look into JEE Advanced 2014 paper, you'll see that these kinds of question has already been asked, right? So what is our learning from this is that many times JEE Advanced previous year problems are also repeated with different values or different ways, but the concept remains the same, right? So I would always request all of you to please also, as well as along with the preparation for JEE Mains, if you had done with the syllabus, I would definitely request you to please go through the JEE Advanced previous year problem as well. Okay, so let us proceed with problem over here. So the problem is talking about that the consecutive terms of a binomial expansion, that is a plus b to the power 12, the consecutive terms of this particular binomial expansion a plus b to the power 12, okay, and the consecutive terms are given as tr plus 1 and tr plus 2. These are the given consecutive terms of the binomial expansion, and they are given to be in GP. Okay, and they are given to be in GP or geometric progression. Now, this is a very interesting way that the question is asked, that it is also trying to include the part of progression. Okay, part of progression. So, what I would suggest over here, so from here, we see that P denotes the number of possible values of R, and Q denotes the sum of all rational terms in the binomial expansions of this particular binomial expansion, that is 3 to the power 3 whole raised to the power 1 by 4 plus 4 cube root of 4 whole to the power 12, right? So from this, you have to find out the Q is the number of the sum of all the rational terms in the binomial expansions, right? So it is a two questions. Okay, first you have to solve for this part, which is the first part. From here you will get the value of the unknown P, and from this part you will get the sum as Q, and then once you get P and Q, you just have to finally report the value of P plus Q. Alright, so please try to solve this. So from here, what I can see, or what I can always tell that since these are the consecutive terms of an GP, so they will be always following the same common ratio, that is T of R plus 2 divided by T of R plus 1 is equals to T of R plus 1 divided by T of R, right? So from here, now I always know the formula, that is T of R plus 1 divided by T of R is simply given as, so this can also be written as simply T of R NCR a to the power that is 12 minus R b to the power R, and NC R minus 1 a to the power 12 minus R plus 1 and b to the power R minus 1, right? So from this particular ratio I'll see, and this n is basically 12, so from this particular ratio I end up getting something of this particular form, that is the ratio is going to be of the form, that is 12CR divided by 12CR minus 1. And similarly, this particular ratio is basically becoming 12CR plus 1 divided by 12CR, right? That is what we are having in this particular problem, right? Now we just need to take the ratio of the binomial coefficient, and from that ratio I will get the value of R, right? So let us proceed with this particular note. So from here I can simply write this ratio as, so I know the formula, that is, so this is a formula, okay. I hope you remember the properties, that is NCR plus 1 divided by NCR is basically given as n minus R plus 1 divided by R, okay. So that is the form, so you need to remember it. So from here you can always write this as 12 minus R plus of 1 divided by R for this part, for this particular part, okay. And for this particular part you can write it as 12 minus R plus 1 bracket plus 1 divided by R plus 1, right? Now from this particular part I will have a quadratic equation in R, that is, you can see it is of the form like 13 minus R multiplied with R plus 1 is equals to 12 minus R multiplied with R, right? So from this part you will see that the, so if you just try to solve this out, you will see a relation, something coming out like this, that is 13 equals to 0, which is a very wrong statement over here, right? Because 13 cannot be equal to 0, so therefore there is no such possible values of R, okay. So therefore no R exists, okay. Therefore no R exists, okay. So from here you can see the number of possible values of R, that is P is equal to 0, okay. The P is basically equal to 0 because there is no such R existing, right? Similarly, if you look at the next part, that is said that in this binomial expansion, that is mentioned like this, okay, which I can always write this as summation R goes to 0 to 12, and that is given as 12CR 3 to the power 12 minus R divided by 4 multiplied with 4 to the power R by 3, right? Now we have to basically find out the rational part, right? So for rational part, this part and this part must be an integer quantity, right? So for that, what I have to do is that this 12 minus R should be some multiple of 4, and similarly R should also be multiple of 3, right? So this is what we are going to do it by hit and trial, that is, I can do, so if I just put R is equal to 12, so R is equal to 12 will generally satisfy my answer, right? So R is equal to 12 will be a suitable solution. Similarly, if I put R is equal to 0, that will also satisfy my solution, right? And similarly, if I put R equals, and if similarly if I put R, so these are the two solutions that I will be having, okay. Now except this R is equal to 0 and 12, if you put R is equal to 3 or any such numbers, you will see that both the relation won't hold simultaneously, right? So therefore the only solution in R you are having is 12 and 0, right? And this R is different from the previous part, okay. So please don't try to confuse yourself, okay. Now if I put R is equal to 12, I will have the term coming out as, so R is equal to 12 will give me the term, that is basically 12C 12 3 to the power 0 and 4 to the power 4, right? So that is the term over here. So I will have this particular term as 256, okay. So that is the term we will have it over here, that is 256, right? So that is going to 256. And similarly, if I put R is equal to 0, the term we are going to have it as, so if I put R is equal to 0, it is going to be 3 to the power 3, that is going to 27, right? That is going to be equal to 27. So therefore the sum of all the rational terms, that is Q, that is going to be 27 plus 256, and this particular sum is coming out as 283, right? This particular sum is coming out as 283, right? So therefore ultimately we have to report the value of, for the value of P plus Q, and that is coming out as 283 because P is equal to 0, right? So that is going to be the answer for this particular problem. Okay, so this is going to be my answer for this particular problem. So from here, you can see the option number B is going to be my right answer. I hope you are also getting the same answer. I hope you all are getting the same answer. Yes, Vidhan. Excellent. So great. So these are very important as well as very simple. Okay. So make sure that you try to practice these type of problems more, because these types of problems are very, very crucial for your JEE Mains paper. Okay. For JEE Mains, you will see most of these types of questions are coming as in repetition. Okay. So fine. So shall we proceed with the next problem? Shall we proceed with the next problem then? Okay. So I hope this part of the problem is clear to all of you. So it is clear. Let's proceed with the next problem. Okay. So our next problem, we have it over here, is basically talking about the coefficients. Okay. So coefficient of the binomial expansions. Okay. Now the given binomial expansion. So again, whenever now these sort of questions are very important, because these are all questions which are basically are required to understand the basic concept behind the general term. Okay. So once you know the general term, you can always play around with the general term to find out coefficient, to find out the rational terms, to find out the integral terms. Okay. So that is all up to you. Okay. Once you understand the basics, everything is clear, right? So it is said that in the expansion of 1 plus x to the power 2n minus 1, it is said that a and b denotes the coefficient of x to the power 30 and b denotes the coefficient of, sorry, 30th and the 40th, 12th term, right? So x to the power 30 is not that, it is saying that it is basically denoting the, this is the 30th term and this is the 12th term. Okay, this is what the question is talking about. Okay, 12th term. Okay, now it is also said in the problem that our a and b are related as 2a is equal to 5b, right? So from this, you have to basically come up with the answer, right? And with this, you have to set up what is the value of n equals to, right? So let us see how we are going to try this question. So this question is going to be very simple. We just need to try to write the general term over here. So our general term, so our general term from this case, what you can write, t of r plus 1 as simple as 2n minus 1 cr, and then x to the power r, right? That is going to be our general term over here. Now, once we have the general term, let us try to understand that the 30th term will be given by putting r is equal to 29, right? So if I just put r is equal to 29, I will get the 30th term, right? So r is equal to 29 will give me the 30th term, which is basically the 30th term is basically equals to 2n minus 1 c 29 x to the power 29, right? And also if I just put r is equal to 11, I'll get the 12th term, that is going to be 2n minus 1 c 11 x to the power 11, right? Now let us try to proceed with this expansion, that is a and b are related as 2 times of a is equals to 5 times of b. So from here I can write this apart as 2 into this 2n minus 1 c 29 x to the power 29 is equals to 5 times of 2n minus 1 c 11 x to the power 11, right? Now from here we have to basically find out for the solution. Now I forgot to say you that this is the coefficient, so we just don't need to write the the part that is the variable part, right? Because we are looking for the coefficient. Okay, so the coefficient part will be only this. I hope this is clear, right? Now we will try to simplify this in terms of, so we will know the formula, that is NCR is basically n factorial divided upon n minus r factorial into r factorial. So what I can write over here as like this is equals to 5 into 2n minus 1 factorial divided by 11 factorial 2n minus 12 factorial, right? Now we will just try to simplify this part over here. So this part and this part get cancelled out, and we'll just try to simplify this part over here, and it will basically become of the form 1 divided by 29 so on multiplied with up to 12. Okay, because if I cancel out this part, so I will just left out with this continued product till 12. Okay, so like this till 12. Okay, and similarly this particular part, and I can cancel out with this particular part, and I will be left out on this. So I will try to multiply with 12, 5 over here, this particular 5, and this is going to be 1 upon, and this part will be left out as 2n minus 12 2n minus 13, and so on as 2n minus 29. That is what we are left out with, right? So, and then this particular 2, I'm taking it over here and writing it 2, right? I hope this is clear to all of you. So from here, what I'm going to do is over here. Now, why I kept this 5 and why I kept this 2 is over here. It's for a purpose. The purpose is that if I try to see, the purpose is very simple. That is, so what I'm going to do over here is that if I write it in terms that if I write it as some multiples of 30 in 29 in 20 and in 12, so that I multiply with 6 over here, such that this is going to be a quadratic product with 30 to 12. So you will see that if you put over here this n minus 12 as 30, this is going to be exactly the same term. Okay, so just by simply manipulating, I'm basically trying to get the some easy solution. Okay, so it's very simple to understand or recollect. Okay, so if I just take 30 out from here, that is multiplying this 5 with 6, so I just have to do the same operation in over here also, right? So I just multiply with 6 over here, so such that it becomes 30. So I just have to do the same operation over here such that it becomes 12. It's become 12, right? Now once I get this, I will see that if I put this n minus 12 as equals to 30, then I will get the same. The LHS is equal to the RHS, right? So from that I will see that n minus 12 is basically equal to 30. Then I will see the convergence. Okay, that is our, from here our n is going to be equal to 21. So from this, if our n is going to be equal to 21, so if you just put n equal to 21, you'll see that this particular LHS is equal to RHS is existing. So from this case, you will get the value of n coming out as option number D. I hope this is clear to all of you, right? Please let me know if this is clear or not. Right? Very simple, straightforward problem. Okay. So I hope this part is clear to all of you. Okay. Even if you have any slight issue or any doubt over here, you can always put that up in the live chat. Okay. Even if you miss out to ask the question in the live chat, you can put that up in the comment section as well. Okay. Don't worry, I will be taking out your answers in the comment section as well. Okay. And if you haven't joined the Telegram group, please join the Telegram group because I will be discussing the doubt there as well. Okay. And if I give any homework in the class sessions or during the live sessions, I will be sharing the solution of those homeworks in the Telegram channel itself. So please make sure that you join the Telegram channel. Okay. And don't forget to hit the like button. Okay. Because that will help me to stay motivated and make some more beautiful content for all of you. Right. So with that, let's work on the next problem. So next problem is again very interesting problem, is that we have for sum n, and that particular sum n that is not equals to 10, the coefficient of the fifth, sixth, and the seventh term of the binomial expansions are in AP. Now again I said that these kinds of questions are very very important for your JEE Mains, because this kind of question has already been asked in the JEE Advanced previous year problems. Okay, so if you just try to look at the JEE Advanced previous year problem, you will see that there are a lot of these types of problems have already been asked up. Okay, so it is said that our n should not be equal to 10. So for that, and the expansion is 1 plus x to the power 1 plus x to the power n plus 4. So all these terms of fifth, sixth, and seventh term are in AP. Okay, fifth, sixth, and seventh term are in AP. Okay, that is what is mentioned in the problem, right? So you have to basically talk about the largest coefficient in this expansion. Okay, very simple. I will tell you how to solve for the largest coefficient. Now it is not talking about the largest term. Whenever it is talking about the largest coefficient, I will tell you how to solve for it. That is very simple. You already know the solution also, because whenever we have NCR, the highest value of NCR is when you put R is equal to n by 2 for n is equal to integer. And if n is not an integer, you just put R as n minus 1 by 2 or R as n plus 1 by 2. Okay, so when R is not an integer, so when n is not an integer, you will have two possible values of coefficient which are having the maximum value. All right, so that is what you already have known so far. So let us talk about what will be the coefficient. Okay, so let the coefficient of the fifth term. So again, let me write the general term over here. So general term is going to be n plus 1 CR x to the power r, right? So for the fifth term will be n plus 1 C4, and the coefficient of sixth term is going to be n plus 4 C5, and the coefficient of seventh term should be like n plus 4 C6. Okay, now these are said to be an NEP, right? So let me tell you that whenever any three numbers, let us say A, B, C, are in AP or arithmetic progression, so therefore it follows a relation that is 2 times of B is equals to A plus C, right? So we are going to do the same thing over here. So whenever any three numbers in an AP, this holds true, right? So we are going to do the same thing, that's 2 into n plus 4 C5 is equals to n plus 4 C4 plus n plus 4 C6, okay? So from this we are going to solve for the solution over here is that, so from this we will solve it as, so what I'm thinking to multiply it with 2. Now why I'm doing it, I will tell you. So multiplying with 2 is basically means adding 2 times of n plus 4 C5, right? So just adding 2 times of n plus 4 C4 C5, sorry, right? Now what is the advantage of doing that is that you will try to understand the advantage is that, so if I just, so from that the left hand side will become 4 multiplied with n plus 4 C5, and that is I can write as n plus 4 C5 plus n plus 4 C4 as one term plus n plus 4 C6 plus n plus 4 C5 as another term, right? Now the advantage is that we are trying to converge this. Now we have already seen that NCR plus NCR plus 1 is going to be equals to n plus 1 CR plus 1, right? So from this particular part is going to be equal to n plus 5 C5, right? And this particular part is going to become equal to n plus 5 C6, and again I can add this 2 and I can write it as n plus C6 n plus 6 C6, right? That is what we will have it over here. I hope I'm doing it correct, right? So from this, I can always write this as n plus 6 factorial divided by n factorial divided by 6 factorial, and that is basically equals to 4 multiplied with n plus 4 factorial divided by 4 factorial divided by n factorial, and this n factorial will get cancelled out with this n factorial, and this 4 factorial get cancelled out with this particular part as left out as 5 into 6, and this particular part and this particular cancel out, and only we left out n plus 6 multiplied with n plus 5, right? That is what we're going to be seeing over here, right? So ultimately you will see the solution is going to be n plus 6 plus multiplied with n plus 5 is equals to, so this part, I hope I am doing everything correct, okay? So all right, so very sorry, I have a mistake over here. So this is 5 factorial and n minus 1 factorial, okay? Extremely sorry, this should be 5 factorial and this should be n minus 1 factorial, okay? So this part should be cancelled like this. So there should be 6 over here only, and this part will be like n will be left out. Okay, so this will be 6 by n. Okay, so that's what we are left out with, right? So divided by 6n is equals to 4, right? So from here you can feel that this is a quadratic equation, that is 11 n square plus 11n plus 30 is equals to 24n, right? Which is simplified, and if you take this on the left hand side, you'll see the answer coming out as is going to be minus of 39, right? And from here you will see this is a quadratic equation whose roots are whose roots are n is equal to 3 and n is equal to 10, right? But 10 is not possible solution, so therefore the only possible values of n is basically equal to 3. So therefore the largest binomial coefficient, so therefore if I take the n is equal to 3, so our expansion is something like 7c, so any general term is 7cr x to the power r, right? So from this 7cr, if I need to find out the largest coefficient, so the largest coefficient, if I need to find it out, it is basically going to be 7c4 or 7c3. Both of them are the possible values, right? Or 7c3, because whenever n is an, so ncr, whenever n is odd, then the maximum value, the coefficient occurs when r is equal to n minus 1 by 2 or n plus 1 by 2, right? That is what you have to understand. And n 7c3 is going to be equal to 35. Okay, 7c3 is going to be equal to 35. So from here you will see that the largest coefficient to this particular problem is going to be equal to 35. That is option number B over here. So all of those people have got option number B are the correct ones. I hope this is clear to all of you. Hello, Rina. I hope you are also following, not only just commenting out. Okay. Please focus on the lectures as well. Okay. So from this, we will have our option as B correct over here. Okay. I hope this is clear to all of you. Please let me know. Excellent, Vidhan. Did you get this option number B, Vidhan? Right. So this part is clear to all of you. All right. So let us proceed to the next problem then. So next problem is again a very interesting problem. Now, this is a very interesting in this case that it is given in the terms that 1 plus x to the power p multiplied with 1 minus x to the power q, right? Please don't consider that p and q are equal and just write it as 1 minus x square whole to the power p, okay? So the question says that you have to find out the coefficient of x and x square, right? I talk this question as an interesting problem because yeah, it is basically a multiplication of two binomial expansions, okay? So for the first binomial expansion over here, you can always write this part as PC0 plus PC1x plus PC2 x square and so on, right? I'm not writing further term after x square because I need to only go up till the coefficient of x square, right? Multiplied with this QC0 minus QC1x plus QC2x square and so on, right? So the coefficient of x and x square are given as the coefficient of x and x square are given as 1 and minus 2 respectively, right? That is what we have mentioned in the problem. Now, in order to generate the coefficient of x, it is only possible when you take x, 1x from here and non-x from here, or you take 1x from here and non-x from here, right? So therefore, the coefficient of x, if I'm looking in the coefficient of x only, so the coefficient of x will be basically PC0 minus of into QC1 plus PC1 multiplied with QC0. That is going to be the coefficient of 1, and that is basically given as 1. Okay. So from here, I will have one equation. So this is going to be one equation that is I will have the equation as P minus Q is equals to 1. P minus Q is equals to 1. That is my first equation. That is my first equation. I hope this is clear. Similarly, for the coefficient of x square, I'll have the coefficient of x square as PC0 into QC2 minus PC1 into QC1 plus PC2 into QC2, right? That is what we have it over here, and that is mentioned in the problem as minus of 2. So from this we can simplify it out as further as that is going to be q square minus q by 2 minus pq plus p square minus p by 2 is equals to minus of 2, right? So from this part I will have it as q square minus q minus 2 pq plus p square minus p is equal to minus of 2, which I can always simplify it, write it as which I can always simplify and write it as so this is going to be become equal to p minus q whole square minus of p plus q whole square minus of p plus q, and that is going to be equals to, sorry, there will be plus 4 because I multiplied with 12, right? So minus of 4 over here, right? This is going to be minus of 4. Okay, so this is going to be minus of 4 over here. So from this part you will see the solution is basically like this. So if you just put p minus q whole square minus of p plus q, so that is only going to exist when if you just put it over here, p plus q is equal to 5, right? So if you just take this as 1, okay, this is 1 and this is 5, then only this will be a solution, right? Otherwise, this is going to be perfect square, so this is going to be perfect square, so it will be like 1 4 9 something like that, right? And since p and q are both integers, obviously they must be integer greater than 0, so they should be like this, right? Now, and p plus q should be equal to 4, then only the solution will exist. So therefore if I take this p minus q whole square as 1, then p plus q is equal to 5. That is the part of the solution that I'm going to have it, because I know this is going to be an integer, right? So, and p plus q cannot be equal to 0, therefore your only solution is going to be like this when I take p minus q is equal to 1 and p plus q is equal to 5. So from here I'll have p is equal to 3 and our q is equal to 2, right? So with this particular solution set of values of p and q, we'll find the value of p square plus q square is equals to 13, is equals to 13. I hope this is clear, is equals to 13. So from here, I'll have option number C as my correct answer for this particular problem. Please let me know if this is clear or not. All right. So this part is clear so far. Great. Excellent. Now, now, so with this part, you try to understand. So mostly the questions we are basically trying to see in the chapter of binomial theorem, they are mostly regarding the general expression of the binomial expansions and doing the summation or finding out the integral terms. Okay, so once you prepare all this particular part clearly, you are very good to go with the any previous year problems of JEE Mains. Okay, so you can pick up any JEE Mains previous year problems and you can try to solve it on your own. Okay, so I have few homework problems with all of you. So this is the first homework problem that I want all of you to please go through. Okay, this is the first homework problem. Please try to go through this particular problem. And this particular problem is very interesting because again you have not given simple binomial expansion. Okay, rather you are given a complex binomial expansions like this form, right, in a third form. Okay, now I will tell you that this is a very interesting and a very easy case. What I would try to do over here is that if you look at over here, there is a plus sign, there is a minus sign, right? So we just try to simply binomially expand this. You will see some odd terms are getting cancelled out and the even terms are getting added up, and the even terms getting added up will become a rational term because this is a square root term, right? So even terms will always have a rational terms only. Okay, so with that particular idea, you can always try to solve for it. And please let me know what is the answer you're having in the comments, in the comment section. Okay, so please let me know in the answer you're having in the comment section. I will go through the answer. Okay, and for the solution of this part, make sure to join the Telegram channel because I will be sharing in the solution in the Telegram channel itself. Okay, so let's proceed to the next form of problem. So this is the next form of problem. Again, very simple. We just need to find out the coefficient. And I have discussed that the theory behind it. Okay, so this is the second form of problem. So please let me know the solution for these two problems that you are solving up. Okay, so I will be looking for your answers in the comment section. All right. So with this, I am done conducting the session on the binomial part. Okay, so you see, if you look at the binomial expansion, so you will see that mostly the simple problems or general terms are mostly asked in the questions. Okay, so we just prepare the general terms and the important properties regarding the terms, the highest term, the highest the maximum coefficient, or the number of terms or number of integral terms. Those kinds of questions you can at least solve the questions in the JEE Mains part. Okay, if you try to neglect the part where the summation of binomial coefficients are asked, it won't matter much in the JEE Mains, but for JEE Advanced it is surely going to matter a lot. Okay, I hope this part is clear to all of you. So with this, let us conclude our session over here. I hope you have no more questions, so then we can conclude our session over here. Okay, so if you have any questions, you can always put that up in the comment section itself. Okay, and if you are starting to watch the session from this particular moment, I would definitely request you to please hit the subscribe button and stay tuned for this upcoming contents. Okay, we are going to come live every day where we will discuss the most important questions of the JEE Mains previous year questions, and with that we are also going to revise the previous year the each and every topics for the maths part. Okay, and along with the maths part, you can see that chemistry part is also going on, right? So don't forget to join the chemistry sessions as well. Okay, because you know that combined preparation of physics, chemistry and maths will actually help you to get that particular desired rank that you're basically thinking of too. Okay, so in order to get a very good rank, you have to understand that you have to keep a balance on this all the three subjects together in order to excel in the exam. So with that particular note,